to market. If you're in the federal US government, there's different issues that need to be taken into account. And so the dynamics of the system of what you would do instead of the keystone, that is sort of more macroeconomic effects and that kind of thing. A typical life cycle assessment isn't capable of actually handling all those dynamics, as well as all the political aspects of the system, to be able to really inform the full decision. The basis of the inputs and outputs and the actual emissions and that kind of thing, that can be helpful, but there's lots of other things that need to go into that decision. And so those dynamics, there's lots of work that's being done to try and integrate generalized computable equilibrium models. Other types of models can be incorporated into life cycle assessment, but the basics of life cycle assessment, I think that issue goes beyond what life cycle assessment can actually do by itself. There's an input-output tool that allows you to look at this from a full system-wide perspective, so it's an economic tool. In order to calculate GDP at the federal level for any industrialized country, they need to collect this data associated with what companies purchase from other companies to produce their product. And so this is a data set that's really robust, and they do a really good job at collecting this data for every country. And so it's economic input-output data. So for a $20,000 automobile, or say $40,000 automobile, you can go through with this model and find out what are all the economic transactions that have occurred in the economy to actually produce that vehicle. And so what has happened though, this was done in the 60s, but what happened later is that we mapped environmental metrics to that. So you can go through and say for a $40,000 automobile, what are all the transactions that have occurred, what are all the economic transactions, as well as what are the environmental emissions associated with all the economic transactions that have occurred in the economy. So that the steel that was produced for the automobile, you can actually go through and look at what the emissions associated with that are and attribute that to the production of the automobile. So it's a way to help with that boundary issue. It's a way to help to be more comprehensive, but there are trade-offs with it as well, because it's aggregated. The U.S. model is 500 sectors. The Canadian model is 120, and that's just a reflection of the smaller economy. But this is an example of the output. So you can look at, this was building $1 billion of transmission line construction. And these are all the types of impacts that you can look at for that transaction that occurred in the economy. And this is the total life cycle emissions. You can actually go into detail and actually find out which sectors are contributing to that. So this is greenhouse gas emissions. This is the total greenhouse gas. And there should be an arrow here showing that this is a breakdown of the individual sectors that are contributing to those emissions. This is just the top 6, but there's actually this is the US model, so there's all 500 sectors you could actually look at their individual contribution to the greenhouse gas emissions to build $1 billion worth of construction line. You can also look at the individual greenhouse gases that are contributing associated with that, and then you can look at the total of that. So that's just an example that the website's at the bottom there, eiolca.net, the Canadian version, the US version, the Spanish, German, and then they're looking at an international model as well that incorporates trade among countries. So it's a free tool that you can use online, and it can be really helpful. But again, it is at a very aggregated level. So if you're looking at electricity, that electricity is the average US electricity generation mix. So that's fine if you're looking at something that's very general, but if you're looking at something that's happening very specifically in one state, it might not necessarily be applicable, so you need to modify the calculations to reflect something that's more specific. Okay, I'm going to skip through all of this and just say, how much time do I have?
Half hour?
Half hour, okay.
20 minutes, yeah.
Okay, perfect. So I wanted to step through an example to get you a little bit woken up and participating. This is a study that I did a few years back, and this is looking at the transport of coal energy. So looking at coal, gas, or electricity, looking at the cost efficiency and environmental implications associated with that. So quickly, the motivation is the electricity industry is one of the most polluting in the US economy, but we are heavily dependent on electricity. This is focused on the US, but you could think of it in the Canadian context as well. And so there's many decisions to be made. So there's aging infrastructure, we need to replace that. There's new existing and proposed policies on the environmental side. And so the life cycle impacts you need to think about in order to make informed decisions about what to invest in and how to operate these systems. But you also need the economics as well, right? You can't exclude the economics in your calculations to make an informed decision. And so what I was looking at here was this area in the US called the Powder River Basin, so it's mostly in Wyoming. where there is a resource of coal that is, it's a lower grade coal, it's a subbituminous coal, but there are vast amounts of it. And it's in very shallow seams. They're deep seams, but they're very shallow, so there's very little overburden associated with them. The other aspect of it is that they're low sulfur. And so with the current sulfur regulations in the US, it's a very attractive fuel because it's cheap, easy to get at, there's lots of it there, and it's low sulfur. The problem, though, is that this is where it's located in the US, and this is a map of the population. So you can see that there's very few people that live in the area where this coal exists. And so what happens is this is transported by rail, and it's transported on average 1,100 miles. A ton of coal is transported at 1,100 miles, which is a very far distance. The rail system in the US, a lot of it is dominated by coal transport. And it's predominantly this idea that this cheap coal exists, but it needs to be transported to where the demand is. So what I wanted to look at was, is shipping this coal by rail the best way to use this resource? So leaving aside the fact that should we even be using this resource, thinking about if we want to use this resource, what is the best way to use it? And is transporting it by rail the best way to go? The other thing to point out is that at the time that I did this in 2005, it was 34% of the coal that was consumed in the US, and 50% of the coal, of the electricity in the US is actually consumed as coal-fired electricity. Does anyone know how much Alberta consumes in terms of producing its electricity from coal?
45%.
70-ish is a little bit closer. So depending on the year, it fluctuates, but 70-ish, 70 to 75% is a good estimate of how much our electricity is generated from coal, and most Albertans don't know that. They know exactly all the details about the oil sands, but they know very little about the fact that we have this very dirty source of electricity in Alberta as well. Okay, so those are the details. So this is the base case. So 50 million tons, this is millions of tons of the Powder River Basin coal that's shipped to each state. This 50 million tons of it is actually shipped to Texas. So I looked at a case study where we were building a new coal-fired power plant, and I was trying to decide, should you build a coal-fired power plant in Wyoming and generate the electricity in Wyoming and ship that electricity to Texas, where the demand is, through transmission lines? Or should you do it the traditional way of actually shipping it by rail and then building the power plant in Texas and generating the electricity there? I'll talk about what happened afterwards, but maybe we could just take a couple minutes for you to discuss among yourselves which of those options do you think is the best option? Yeah.
Did you look at DC power lines as well as AC?
Yeah, it's about 1,000 miles of transmission,
Yeah.
and so at that level, a dedicated line on DC,
Yeah.
HVDC would make the most sense because you're going so far. So if you could just think about which of these two options, this is the coal in Wyoming, this is it being shipped by rail to a power plant in Texas, very close to where the demand is in Texas. The other option, option 2, is to actually generate the electricity in Wyoming and ship the electricity through power lines to the demand in Texas. So just take 2 minutes, discuss among yourselves, both economically and environmentally, which of those two options do you think makes sense?
You guys know how much?
By rail,